so fidgety, but it is. Okay, y'all. Let's start with this. You ready, brother? Okay. We had a diagram last time, right? Do you remember? Do you have notes on it? Let's get it up. Tell me what to draw. Yeah. So we can go from volume to mass to molarity, right?
Yeah. Oh, was it the circle?
Yeah.
Okay.
We have it written down?
Yes.
You too.
You're gonna put particles on the top.
What goes in the middle?
Moles.
Okay. All right, moles. Then what?
Volume down.
Volume down. Okay. And what do I do with the volume? How do I go from moles to volume?
You multiply or divide by 22.1.
Okay, so if I want to, this is down is multiply or divide? Multiply. And the other way is divide, right? And this is by 22.4.
Yes.
Okay. And how about over here?
You put grams.
Grams, good. What do I need to do?
Divide or multiply by.
Which one's which?
You divide.
Go from moles to grams, what do I do?
You multiply.
Multiply. And to go from grams to moles, I divide.
Yeah.
By what?
Molar mass.
Molar mass, good. And my last one?
Particles.
Particles. Actually, let me do that one a better way. Okay, multiply or divide by? 6.02 times 10 to the 23rd.
Yes.
It's Avogadro's number. It's the number of particles in 1 mole. It's the number of particles in 22.4 liters. By the way, this should be liters of a gas. It's the number of particles in, if I'm looking at oxygen, it's the number of particles of oxygen in 32 grams of oxygen gas. Okay, so this would be divide, this would be multiply, right? This is just going to be super, super useful. It's going to let me convert between one form and another, and we've got to be able to do that.
I have a question.
Yes, ma'am.
So you put, or they put volume, but is it like just a broader, like any measure of volume, or will it always be liters?
It's going to be liters of gas.
Okay.
If I wanted to go to something else, I'd have to have a conversion factor
Okay.
to go from liters to
Whatever other.
ounces or
Okay.
something.
I was just thinking.
Okay. All right. Let's do a little review problem real quick before we jump in too far. So let's see. Okay. I'm just losing my stuff here. Let's do this problem. So I've got a gas here, okay? And it's 27.29% carbon, and it is 72.71% oxygen. What I want to know, first of all, is what is its empirical formula, okay? So I've got carbon, I've got oxygen. I can figure out an empirical formula based on this, right? So what do I need to do?
You need to find how many moles of each.
Well, I've got a percentage right now of carbon, right? So 27.2, is that 9?
Yeah, that's 29.
Okay, 0.29 times, actually I probably want to go like this, right? Times, how many, how much is carbon? How much is the mass of carbon?
15.99.
No, not 15.
12.
That's
12.
oxygen, you think of.
Yeah, it's 12.
12 point,
0, 11.
12.01. We'll do that, right? So somebody run that number for me. It's gonna be a long day if we're not doing this. That's what we're here for.
I got 3.277.
3.277.
Yeah.
Okay. And then how about for oxygen here?
15.999.
So what do you get for the number?
$11.62.
11.62. Okay. Anybody else have that?
Yes.
Okay. Okay. Now, I'm missing something here, aren't I? Where were we? Goodness, are you kidding me? No. Okay. All right. So how am I going to figure out my formula for this?
Do you add them both together? Or what do you mean formula?
Well, we're trying to figure out the empirical formula, right? So 72% of my mass is coming from oxygen. 27% of my mass is coming from carbon. I've run these out. That puts me at 3.277 grams and 11.62 grams. And I've got to get from this to some form of an empirical formula, right? So the simplest whole number formula. There's something wrong with this. Bear with me just a minute. I don't think they have the right numbers here. They don't have hydrogen up here at all.
Yeah, I think that's a completely different.
This is, I'm writing the numbers they've got, but it doesn't work out.
To be honest, that looks more like CO3. And I'm not even sure if that's any.
We're going to move on to the next thing. Okay. This has been one of those days. Has it been one of those days for you?
Yes.
Yeah. So man, I've had brain fog all day. Let's just dive into molarity. Okay. So you need to write these things down. Molarity. Molarity is referring to a concentration. What we want to know is how many moles of a substance per liter solute, or solvent. So I'm going to throw some vocabulary at you, okay? Get that down first. Maybe this should say, instead of substance, why don't you write solute? Solute. Okay. So this has to do with what we call solution chemistry. That doesn't mean the answer. A solution is just, it's a mixture of different things, okay? Sometimes, well, specifically we're going to refer to things that are homogeneous mixtures. You encounter this all the time. If you were to have some Kool-Aid, right? What are the 3 ingredients you know are in Kool-Aid?
Sugar.
Sugar,
Water,
water,
the mix.
and the color, the powder, right? The stuff that's probably going to, give you diabetes or cancer or something someday. So, so if I were to draw a glass with Kool-Aid, right? I've got a lot of like water drops everywhere, don't I? Lots and lots and lots and lots and lots. And then I've got the stuff that makes you happy, the sugar, right? You love that. By the way, I've got lots more water than I have sugar, don't I?
You should.
Sometimes.
You hope I do. And then there's the color, right? Why don't I go with green, because you can kind of see that, right? Okay, so I have 3 substances here, right? When we talk about, this is a solution, I've got 3 substances that are mixed together, they're evenly distributed, it's homogeneous. Now, the question is, which one do I have the most of?
Water.
This one I have water. So by definition, your solute is the substance that you have the most of in a solution.
I don't know the salt.
Did I say solute? I
Yeah,
meant
you said
solvent.
solvent.
My goodness. I've told you, it's one of those days. Solvent equals the substance in greatest quantity in a solution. That leaves me with one other thing here, and that's solute. That's the substance in lesser quantity in a solution. Okay, so it's pretty easy to pick up here. I've got a lot of water, I got a little bit of sugar, I got a little bit of food coloring, right? So it's easy to tell which one's my solvent, which one's my solute. The solvent is always the one that's in greater quantity, right? So this one makes sense. But what if I had 2 liquids together? What if I had 20 mLs of H2O mixed with 21 mLs of alcohol? Which one is my solvent? Alcohol, because it's the one that's in greater quantity, right? And that would make water my solute. Of course, if I just added 2 more milliliters of water, that would turn water into the solvent. So to a certain extent, when we're getting just down into technical definitions, it's just, but practically speaking, in this class, so often what we'll be referring to are what we call aqueous solutions. These are solutions in water, where water is the solvent. And you need to know that term. Okay, aqueous solutions. Water is the solvent. Directly relates to our concept of molarity. Had you read the wrong thing right here? This is not solvent, it's 1 liter of solution. You got to fix that. I misled you, and that will cause you mistakes later. You weren't paying enough attention, it doesn't really matter. You got it good now, right?
No, I've always been.
You need some sleep.
Yeah, I definitely do.
Me too.
I ended up staying up till 6 in the morning because I couldn't fall asleep.
So sorry.
And then I ended up missing my first class today because I ended up waking up late and slept through my alarm.
I understand about that. All right. So let's do a little bit of this. Let's calculate some molarity. It's moles per liter. So let's do let's do some ammonia. Okay. So I want to have 0.3 grams of ammonia, NH3, in 1 liter of solution. I want you to tell me what my molarity is, right? Molarity is moles per liter. I don't have moles yet, right? I have 0.3 grams, but I can get from grams to moles. What I need to do there is I need to go 0.3 grams times whatever the molar mass is of ammonia. So for that, I need a periodic table, right?
So nitrogen is 14.007.
Okay, I'm going to write that down over here. 14.007 for nitrogen.
Hydrogen is 1.0079.
1.0079. I'm not dealing with all that. I'm going to go to like here, right? So I'm going to say this is, well, I have NH3. So how many of these do I need?
You need 3.
3. So I need 17 grams. Now, I want you to think about this for a second. We're about to do some dimensional analysis stuff. This is grams per what? Grams, well, right, this number is grams per, he just gave me, he said, you know, your atomic number for nitrogen is 14 and your atomic number for hydrogen is 1, but you got 3 of them, so that's 17 grams per mole, right? Because we're looking at molar mass here. So 17 grams per mole. Now, this doesn't work like this though. I know that it's 17 grams per mole, but if I do that, I'm going to get grams squared over moles, and that doesn't work. So I've got to flip this thing around, right? So I've got to go 17 grams per 1 mole, okay? And when I do that, what do I get?
0.72.
0.17 moles?
Yeah.
Okay, good. Can somebody else run the numbers? Let's just confirm.
Yes.
Okay, good. 0.17 grams. Now this is in 1 liter of solution, so I can just come in and I can put 1 liter here, right? Which tells me that this is a, what we call a 0.17 molar. That's what the M stands for. I can also write it like this, 0.17 molar solution. This is telling me my concentration. How much ammonia is there? I can express it in a number of ways. I can express it in terms of grams. I can express it in terms of moles. I could have expressed it in terms of particles. Of course, you know from that chart that we have, we can get all over the place from that. I could do that and go, hey, if this same amount were a gas, how much volume would it have at STP? And so you multiply that 0.17 times 22.4, and you can get there, right? Let's do another one, because I think we're going to need it. All right. Let's do a 0.7 gram solution of CH2O in 0.5 liters of solution. what do I need to do?
Molar mass.
I need to figure out my molar mass. So figure out molar mass for CH2O.
Carbon is 12.011. Hydrogen is 1.0079.
1.0079.
Yeah.
Okay, and oxygen.
Oxygen is
15.99. Okay, good. So I've got two of these, right? So when I do this, I get, well, those are nice. They cancel out, right? So 16, 18, 28 plus 2 equals 30. Does that seem right? Is that the right number? Okay, so the molar mass of this is 30 grams per mole. Okay, I'll start off with this. What do I do?
0.7 times
0.7 grams.
1 mole.
1 mole over 30 grams. Okay, and what does that number come out to be?
0.023.
0.023. Is that right? Didn't seem right. Run that again.
That's what it is.
0.7? Oh, divided by. I'm like, there's no way 0.7 times 30. Bless my heart. Give it to me again. 0.023?
Yes.
Okay, thank you. Y'all are great.
I was like,
I'm telling you, it's one of those days. Over how much?
F.
Over a 0.5, 0.5 liters of solution. I want molarity. That is not molarity. Molarity is moles per liter, right? So what do I have to do to get this into moles per liter? I got to multiply it by 2. So times 2 equals 0.046 over 1 liter, right?
Wait, why did you multiply by 2?
Because this is not molarity. Molarity is always in moles per liter solution. I have a half liter solution.
Oh, okay.
So I've got to multiply it by that to get that. Okay. All right. You guys feel good on that one? Good. Let's do some more. Okay. Let's see what the book wanted you doing. They didn't want you losing pages. I got a page flipper somewhere. All right. Okay. It says a 355 milliliter soft drink sample. So 355 milliliters of solution that contains 0.133 moles of sucrose. .133 moles of sucrose. And it wants you to calculate the molar concentration.
oh, the funny thing is, it already has the moles.
Yeah, it's kind of there, right? So I need to get to this molar concentration. I need to get moles per liter, right?
So you need to change that milliliters into 1 liter.
So I'm looking for mole. Remember, I'm looking for moles per liter, right? I've got moles, right? I've got 0.133 moles. I've got that over what?
355 milliliters.
0.355 liters, right? Okay. I want to get this into moles per liter. So what do I need to do? One thing I can do is cross multiply and divide. When I'm telling you it's been a day, I mean it's been a day.
Come on, I might be able to see you. Come on. Let me open my phone.
Do the math on that one. What does it come out to?
So it looks like you need to multiply that whole thing by 2.81690141.
Where are you getting that from? Where are you getting that from?
So dividing 1 by that bottom number.
Why am I doing that?
Well, that's the number you need to multiply to make that liters, 1 liter.
I am lost. I don't know what you're telling me.
Oh, he's trying to get to 1 whole liter, not like, because that's less than a whole liter.
Okay,
You're supposed to have 1 liter of solution, aren't you? Is that?
Then you cross multiply and divide.
That is,
so it looks like this is 0.3746479 moles per liter.
I got 2.66.
what's crazy is I've already done all these. My brain is just sitting here going,
I'm competing you one time.
I'm staring at my own work going, I don't know what I'm doing.
Something like that.
That's not the excuse. I think it's the lack of sleep. I'm looking at the wrong thing. I'm looking at the wrong everything. All right. I've got 355. Give it to me in molarity.
So the
355 milliliters, right? Of a soft drink. And that 355 milliliters contains 0.133 moles, right? So now what is I want to know what is the molar concentration of the sucrose. So why do I have what I have? It should just be 0.133 divided by 0.355, yeah? And what do you get?
2.66.
That's not the right answer.
what did you get?
The right answer is 0.05,
Yeah, that's not what I got either.
which I got. Or is it, no, that's the answer to the next question. That's right, it's 0.375 molar.
Exactly what I
Is
had.
that what you got?
Yeah, exactly.
Okay, so how'd you get that?
So, since you're trying to turn that bottom number into a 1 liter,
Yeah.
if you divide 1 by that number, you get the number you have to multiply the top by in order to change the whole thing into moles per liter.
Come do what you're talking about. Come show me what you're talking about. Your words don't make sense. Do it down here.
Hang on, I need my calculator.
It's a humbling experience.
So if you divide 1 divided by 0.355, you get 2.817, and then you multiply that by that. And you get 0.375.
That's a ridiculous waiting number. Let's try. What is that? So I apparently lost my brain for the day. Let's see what we can. Let's get their solution, okay? They're saying moles equal moles of solute over liters of solution, right? So when we do that, we have 0.133 moles, right, of sucrose over 355 milliliters of solution, but then we need to take that and we need to multiply it by 1 liter of solution over 1,000 milliliters. I shortchanged that by simply moving my decimal point back and saying it was 0.355, right? And then it's just saying when you run that out of your calculator, it should come up with the answer. So run your calculator, see what answer you get. Just running it like that. What? Is wrong? Yes, it's the right answer, which is exactly what I should have had quite a while ago, and we shouldn't be sitting here looking confused.
Did you get the wrong answer on the paper, or?
No, I had the right answer. I don't know what I did wrong. I had the right formula. I looked at it, I stared at it, I thought about it, I pondered it. I went,
Maybe you accidentally hit the wrong sheet.
I don't know what I did.
So all you essentially have to do is just divide both.
Yes. Yeah.
I made it so much.
Let's do another one.
You
You made it so
It
complicated.
made sense though. I mean, I understand like how you got there.
Let's do another. I've got 0.97 grams of, am I doing the right thing? No, let's do 0.9. Let's do 977 milliliters of a 0.2 moles of solution. Solute. So what do I need to do?
Change your
Looking for moles per
milliliters.
liter, so I need to go to 0.2 moles, right? I need to divide that by.
0.977.
I can go either go 0.977 liters. He skipped a step, which is what I did last time. If we want to do it the long way, we'd go 0.2 moles over 977 milliliters times 1 over 1,000, right? That's liters per milliliter. It's going, that math is going to equal that math. So when I divide 0.2 by 0.977 liters, what do I get?
2047.
Say it again.
2.047.
2.047. Did y'all get that same number?
Actually, I got 0.2047.
Okay, let's do it again. You get 2 different answers. You run it again, right?
Yeah.
What'd you get? Your,
I got the, hold on, I'm like rerunning it.
okay. Did you run yours again?
I got 0.2.
You got 0.2? Did you run it again?
It's 0.2 mole. Yeah, I did it wrong.
Okay.
I did 2. I just saw the point.
Okay, so 0.2 what?
2047.
2047?
No, not 22.
One more time.
0.2047.
Okay. All right. And this would be capital M, right? Molarity, right? It's concentration of moles per liter. Okay, now let's start getting complicated, because these do get complicated fairly quickly. All right, this is a sample right out of your book. It says a 350 milliliter, we just did that one, didn't we? It says a teaspoon of table sugar contains 0.01 moles of sucrose. Okay? What is the molarity of sucrose if a teaspoon of sugar has been dissolved in a cup of tea with a volume of 200 milliliters? So I'm looking for moles per liter, right? So this isn't too hard. What do I do here?
Mole.
So it's 0.05.
200 milliliters times 1 liter over 1,000 milliliters, right? So what's my answer?
0.05.
0.05. Good. Let's do the next one. how much sugar in mole, how many moles of sugar is contained in a 10 milliliter sample of the soft drink. So what we want to know is how many moles milliliter of solution. This goes back to our soft drink question. So remember in that soft drink question, what we had was, what was our molarity there? Do you remember that one?
0.375.
0 what?
375.
0.375?
Yeah.
Okay. So how many moles are in 10 milliliters of a solution with this molarity, right? Let's look at this molarity. So I've got 0.375, what is this? Moles
Moles per
per
liter.
liter, right? I want to know how many moles are in just 10 milliliters of that solution, right? They write it out all funky. The way I was always taught to do this is cross multiply and divide. So, I want to know how many moles are in 10 milliliters of the solution. So I need to go 10 ml, right? And what I'm looking for is the number of moles. Of course, I've got liters here, I've got milliliters here. That doesn't really work out, so I've got to convert this. How do I convert 10 milliliters to a liter? I multiply by 1 over 1,000, right? And so what's my answer?
Is it 0.01? No, just kidding.
What's 10 divided by 1,000?
0.021.
Yeah, I was
So if you wanted to take a shortcut, you could just divide that by 100, because then it would just go straight to 1 liter instead of 10 liters.
I don't know what you just said.
I think
So since that is 10 milliliters,
This is off. I'm sitting here going, that doesn't seem right. It's 0.01. Okay? There's 100 of those in a liter.
yeah.
Well, I want to keep it. Sometimes the things that work here don't, like I'm not saying it doesn't work, but for everybody to understand it, we want to keep it fairly simple. That makes sense?
Yeah.
We're just looking, bottom line is we're looking to convert 10 milliliters into liters, right? So the answer is, it's going to be 0.01 liters, okay? So this is where we do what's called cross multiply divide, right? I'm trying to solve for this, right? So what I do is I multiply this times this and I divide by that. And it should always allow me to solve for this other variable. So let's try that real quick. So 0.375 times 0.01 gives you, what would it give you?
0.00375.
375, which when we put in scientific notation, comes out to be 0, or when we do sig figs, comes out to be 004, which should be the right answer. Just confirm that. That is the right answer. I want to show you this cross multiply and divide business for a minute, okay? Just to, are y'all familiar? Who's not familiar with it? Everybody's done it? Everybody knows it? Life's good? Great, okay. First time I ever learned it was in chemistry, way back in the day. So I wasn't sure if we had that or not. All right, so what did I get here? This is the number of moles, right? This is the number of moles that would be present in, actually not moles, this is the, yes,
That's the
number of moles that would be present in this many liters, right? Now I could take this, I could figure out how many actual particles there were, right? I could multiply this number by 6.02 times 10 to the 23rd. That would literally tell me how many molecules of that there are in there. And that can be a very useful thing at certain times. But first, we're going to do the next problem. So the next problem says this. What volume in milliliters of sweet tea contains the same amount of sugar as the 10 milliliters of soft drink? So I want to know volume of tea that equals, what is this? 10 mLs of soda. And we're talking about in terms of molarity, in terms of sucrose. Okay? Means volume T has the same amount of sucrose in 10 mLs of soda, right? So I know what this was. What was my molarity there? Or what were my moles?
0.004.
0.004 moles. So I actually, really, all I'm trying to figure out is how much of this sweet tea do I need to come up with 0.004 moles of it. And so what was my molarity of my tea?
Was it the?
It was a couple problems back. You all remember doing it? Got it in our notes? It's 0.05 molars. So I've got a 0.05 molar solution, moles per liter. I want to know how much of that do I need to have 0.004 moles. Of course, I can set this up as moles per liter, right? 0.05 moles per 1 liter. And then over here, what I'm really looking for is this volume. Which if I have set this problem up correctly, we should be able to solve for, right? So run those numbers, see what you get.
I got 12.5.
That's not right.
0.08
0.08 what?
liters.
Everybody feel okay right now? Ingrid, how you doing?
Yeah, I got it.
Okay. Now I want to convert this from liters to milliliters. What do I need to do?
Multiply
By?
1,000.
1,000, which will give me what?
80.
80. That's the answer. That's good. Let's come over here, let's do the next one. All right, distilled white vinegar is a solution of acetic acid, that's CH3CO2H in water. It says that we have a 0.5 liter vinegar solution that contains 25.2 grams. So I'm going to write that down, 25.2 grams of acetic acid in 0.500 liter solution. Okay? It wants me to tell it what is the concentration of acetic acid in units of molarity. So molarity, I need to get to moles per liter, right? So what do I do with this to get to moles per liter? Times what?
Molar mass.
I need to find its molar mass. So do me a favor, let's just look at this. How many carbons does this have?
4.
Huh?
2.
2?
Of carbons.
2 carbons. How many oxygens?
2,
2?
Oh,
How many hydrogens?
4.
4.
Okay. So this is equals 2 times 15.99, right? This is equals 2 times 12.01, and this equals 4 times 1.01 or something like that?
001.
Is it 001?
No, actually 0079.
Yeah, that's going to round it up, so 01, okay. All right, when I do that math, I'm going to get 4.04, I'm going to get 31.98, I'm going to get 24.02. Add that up, what's that? It's going to be 32, 36, 56 plus 4, 56, 60.04. Does that seem right?
Yeah.
Don't trust me. Not me good.
Well, I mean, it does make sense.
Yeah, but I'd like you to do the math. Do it. Let's go.
That is right.
Okay.
I did it in my head.
Okay. All right, so I've got grams on top here, so I need grams on the bottom down here, right? So this is going to be 60.04 grams per 1 mole of acetic acid, right? Good, so I've got my moles when I do this, and then the other thing I've got to do is I've got to put it over 0.500 liters, right? So I multiply that times let's do this, let's not add steps. We'll do the first part first. So what do I have here? To do that math, what do I get?
0.41.
0.41. What's this going to be? Moles over how much? 0.500 liters. If I want to convert this into molarity, then what do I need to do?
Times 2.
Double it, right? So that's going to give me 0.82 moles per 1 liter, right? Or I can just say 0.82 molarity. Let's see, was that the right answer, I hope? I got 0.84.
Oh, I think it's because the point 4.
They rounded up
Yeah.
for 42. It is 0.41.
Okay.
But I think they.
Okay, well, that would do it. All right, well, very good. Okay, let's go on to the next one. All right, the next problem. Let's do that. Determine the volume of a solution containing a given mass of solvent or solute. Sorry, so it says what volume of that solution 0.839 molar vinegar has 75.6 grams of solute. So I've got my molarity, right? So 0.839 moles per liter. I want to get to grams of solute. I want to know how much 75.6 grams of solute is. I probably started on the wrong end of this. I probably need to get from grams to moles. So let's work backwards real quick, okay? So I've got 75.6 grams of solvent, a solute. And I need to get to moles of solute. So I use my moles, or my grams per mole, right? So 1 mole over whatever my formula mass is here, right? Which we did, right? 60.04.
Yeah.
Okay, so when you run that, what do you get?
I got 1.26, that's rounded.
1.26 moles. Same number? Okay, good. So I've got 1.26 moles. And now what am I trying to get to? I want to know what volume is going to have 1.26 moles, right? Okay. So let's take our 1.26 moles. And I want to multiply that by my molarity, right? I've got 0.839 moles per liter. I want to make sure I've got everything on the right place. So 0.839 moles so that my moles will cancel. I'm drawing molarity, not moles. Over 1 liter. Okay, and so what do you get when you do that?
Oh, 1.5.
Yeah. That's it. Get it? Good. Good, good, good. Okay. Let's do another problem similar to this. O is good. We'll take O. Okay. So we want to know the volume of what volume? Of 1.5 molar KBr solution as 66.0 grams of solvent or solute. Okay. So I've got 66 grams of KBr, right? So the first thing I've got to do is multiply 1 mole over whatever the formula mass is here. So potassium bromide.
Yeah, but one line
It's all good. You're in the right room. All right, so potassium.
39.09.
Yeah, we'll write it over here. Potassium equals 39.09, and bromine is
79.9.
79.90. When I add those two up, what do you get?
118.99.
118.99. So 118.99. That's going to give me the moles of KBr, right? And ultimately, what I'm looking for here is what? I want to know the volume. So I need to multiply this times my moles per liter, right? So I've got to invert that. I want my 1.5 moles down here, and I want my 1 liter up here. I can multiply all the way across the top and then divide by the bottom. When I do all that, should get the right answer.
Took me a second. I looked
it's
down
okay.
and I looked up.
Basically, it's 66 divided by that, right?
I got 0.369.
So like that too. And what are my units here?
Uh,
Liters, right? Good, 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 good. We're getting somewhere. All right. Ooh, dilutions. Where are we at? We are actually about where I thought we would be. That's pretty good for me. All right. Dilutions. Let me just read to you a little bit. Dilution is the process whereby the concentration of a solution is lessened by the addition of solvent. For example, a glass of iced tea becomes increasingly diluted as the ice melts. The water from the melting ice increases the volume of the solvent and the overall volume of the solution, thereby reducing the relative concentrations of the solute that give the beverage its taste. A simple mathematical relationship can be used to relate the volumes and concentrations of solutions before and after the dilution process. According to the definition of molarity, the number of moles of solute in a solution is equal to the product of that solution's molarity and its volume in liters. So just by definition, what it's saying is moles equals molarity times liters. If I know molarity and I know volume, I can come up with the number of moles, right? We've been doing problems like that, right? So if I have, just for a simple way of doing this, if I have a 0.5 molar solution and I've got 0.2 liters of it, how many moles do I have? I multiply 0.5 molarity times 0.2 liters. What do I get? 0.01 moles.
Actually, no, just be 1.
Is it just 0.1?
Yes, it literally just 1.
0.1 moles, right? Let's do another one. If I have, say I have a 7 molar solution and I've got 2 liters of it, how many moles do I have total? 14, right? That simple little thing is a step we don't want to skip. We need to be able to do dilutions. We need to be able to do that. So let me give you one, okay? This one I'm just going to make up, and then we're going to do one off your paper. So let's say I've got a half liter of a 0.4 molar solution, and I'm going to dilute it to a 1 liter solution. Okay? So, based on what we just said, I can figure out my number of moles by multiplying 0.4, right? Or excuse me, yeah, by multiplying 0.4 molar times a half a liter. I didn't have that point, I just kept it simple, didn't I? It was just 4 molar. So let's do that. How many moles do I have if I have a half a liter of a 4 molar solution? 2 moles, right? 2 moles per liter, right? So this would be a 2 molar, well, I'm sorry, it's 2 moles. Oh. Now I want to dilute it to a 1 liter solution, right? So I just put my 2 moles over 1 liter. And now my 2 molar just became, or my 4 molar just became a 2 molar solution. The number of moles per liter got cut in half simply by doubling the quantity of the liters. That one's easy, right? You don't have to think much, but it'll change as the numbers get more complicated. So let's say I've got a 0.33 liters of a 0.9 molar solution, and I want to dilute that to a 0.57 liter solution. That gets more complicated, right? You're not doing that one in your head. you go ahead and use your calculator. But the process is going to be the same, right? I still want to know, I want to come up with the number of moles, so I multiply 0.33 liters times 0.9 molar, right? And then I just set that over 0.57 liters. So even though the numbers got more complicated, the formula is still super simple to do this dilution, right? So what did you come up with?
0.52.
Anybody else get the same thing?
Yes.
Awesome. Okay. All right. Let's continue on with some of this concept. So the book says expressions, it wrote it like this, by the way. N equals M, or sorry, capital M and L, where N, by the way, is the number of moles. You need to know that. It's not going to go away.
What is that, N?
N is the number of moles. You're especially going to need to know that, like for something later on called the ideal gas law, P equals nRT. When you see N, it's saying how many moles is there. If you don't know that N always equals the number of moles, you'll get thrown, even that, you know, by something silly. You don't want to do that. You just have to know this. It's not going away, okay? Expressions like these may be written for a solution before and after it is diluted. So, N1 equals M1L1, or N2 equals M2L2. Okay, so the number of moles before equals the molarity before, I keep writing lowercase m's, times the volume before. N2 equals molarity final times volume final. This is where the for each subscripts 1 and 2 refer to solutions before and after dilution respectively. Since the dilution process does not change the amount of solute in the solution, then N1 equals N2. That makes sense, right? These other numbers may change, but the number of moles will not. Thus, these equations may be set equal to one another. So you can say that M1 L1 equals M2 L2. Fair enough? This relation is commonly referred to as the dilution equation. Although the equation uses molarity as the unit of concentration and liters as the unit of volume, other units of concentration may be used as long as the units properly cancel per the factor label method. Reflecting this versatility, the dilution equation is often written in the more general form: concentration 1 times volume 1 equals concentration 2 times volume 2. Let's quickly get to a problem because I'm getting sick of reading. Okay. Here we go. If 0.850 liters of a 5 molar solution of copper nitrate is diluted to a volume of 1.80 liters by the addition of water, what is the molarity of the diluted solution? So it's saying, hey, use that formula, 0.850 liters times 5 molar equals 1.8 liters of this unknown molarity, right? So I should be able to just multiply these, divided by that, to get that, right? Yeah, so what do you get?
2.36.
2.36 molar solution. That's correct.
You said you multiply those and then divide by 1.8.
Yeah, whatever's happening on this side equals what's happening on this side. So I can these multiplied together equals these multiplied together. I multiply these together and divide by that, and that will give me that. Okay? All right, that one's super easy. Volume of a diluted solution. What volume of we're trying to find the volume. 0.12 molar HBr solution, hydrogen bromide, can be prepared from 11 mLs of 0.45 molar HBr. They wrote this question oddly, didn't they? Let's look at my initial. My initial is how much? What's my initial concentration? 0.45 molar. What's my initial volume? 11 mLs, right? Equals, what's my final concentration? 0.12 molar times some unknown number of mLs. So even though that was written oddly, phrased oddly, the math is still super simple. Multiply these two, divide by that, and I'll get the right answer. What'd you get?
41.35.
I got that too.
What'd you get?
41.25.
41.25 ml. If I want to convert that into liters, what's it going to be?
That would be 0.004125.
You went a little crazy with the zeros.
It's not 0.4125.
Should be point. Well, all I have to do is divide this by 1,000, right?
So it'd be
0.04125.
Oh yeah, I did do one too many years.
Okay. Good. Let's do that. We're out of time.
We have 10
We
minutes.
have 10 minutes. I'll take it.
Also, surprisingly, my phone percentage hasn't gone down at all since I got the class, and I don't know why.
All right. What volume of KOH is required to prepare a 5-liter solution? What volume? Oh, there. Okay, so I have a 1.59 molar KOH. Times a certain amount, and when I dilute it, it's going to come out to be 5.00 liters of 0.100 molar. Okay, so I've got molarity on both sides. I've got liters on one. What I want to know is how much of this, right? How much of this in liters? So this is my initial. I can tell that because I have the greater molarity, right? 1.59 molar. This is my final. I'm diluting to 0.100 molar, right? So I've got my initial. I don't have my initial concentration, or I do have my initial concentration. I've got 1.59 molar times, now I have a question mark here. I don't know what this is. We're solving for this. But I know that it's going to come out to be 5.00 liters. Actually, let me rewrite. Let me put that in the same form, or order your formulas in. I'm going to have 0.100 molar times 5.00 liters. So I multiply and I divide.
The answer is 0.3144.
I'll double check that.
I got 0.03144.
Okay, third opinion.
I got the same as the first one.
First one.
Probably just the one.
Okay, run yours again. Just double check.
You might have accidentally, wasn't actually zero somewhere.
Yeah, it's
No,
easy.
still getting the same thing.
I'll do it one more time. Okay, so I'm going to start with 0.1 times 5, and I'm going to divide that by 1.59, I get 0.3144.
What are you doing?
This times this divided by that.
Oh, I was putting the decimal in the wrong place for the 5 liters. Okay.
Okay.
Okay, got it.
Well, there you go.
I got it. Yeah.
Perfect. Okay. What volume of a 0.575 molar solution of glucose how much of a 0.575 molar solution of glucose can be prepared from 50 mLs, 50.00 mLs of 3.00 molar solution of glucose. Okay, you'll set it up.
So 0.26.
Right to me. These are the easiest ones, right? Now, one thing I need to do probably is take my 50 ml and convert it into liters, right? I'm just going to divide that by 1,000 times 3.00 molar. I know that that's going to be equal to this quantity times 0.575 molar. So do that, divide by 1,000, divide by that.
Okay, you put times that, divided by that.
I did it right.
The in, there in, that's supposed to be divided.
No. Here's my formula. Right.
Yeah, exactly, you would have to divide that last one.
No. No.
Yeah,
It's concentration. This is my concentration 1 and volume 1, right?
yeah.
Equals concentration 2.
No, I mean, you would have to divide the whole, okay, never mind, I didn't see the equal signs in the middle. I didn't see the equal sign in the middle.
You could really get me, the way my day's gone, you could really get me going. You gotta be careful. All right, so what did we get for our answer?
0.26.
2.26.
No, 0.2.
Just 0.26.
0.26?
0.26, yeah.
0.26 liters, right?
Yes.
Everybody got that? Good. We're doing good. I like it. All right. You know what I neglected to do? I did not pray before we started. I was praying in there. I didn't pray in here.
That might be why it's not going so well.
I'm telling you, we're doing better now. The Lord's been very gracious. But boy, did I have a rough start to class. All right. Okay. That was 43. Let's do 44. What time is it? This would be a great
Well,
stopping
we have
point.
to-
This is a good stopping point. Saved by the bell. All right. Well, let me pray for us right now. Father, thank you for helping us to get through this difficult stuff, and despite brain fog and lack of sleep, and that it's a Monday after a test, and all these difficult things. Help us to retain these. Where our minds can make something very simple, very, very complicated. We can think ourselves into a loop. Your word says that the wisdom of the wise can confound them, can blind them. Lord, help us not to be wise in our own eyes, but to be humble and simple. Holy Spirit, would you bring these things to our remembrance each day? We pray in Jesus' name.